so section 4.1 is on the chain rule. So it says, based on our current knowledge of derivatives, how would you find the derivative of y equals 3x minus 4 quantity squared? So hopefully what you guys did is you multiplied 3x minus 4 by 3x minus 4, and you got 9x squared minus 24x plus 16. And then you found the derivative y prime from there. So you get 18x minus 24. All right, you guys all get that? All right, pretty basic. But it says, what if you have something like f of x equals 3x minus 4 raised to the 15th power? Please do not expand. Right, there's an easier way. So do not expand that. Some of you are, you would do it if I asked you. You would. No. Right. So you don't multiply it out. Okay, so it says in order to do this, we use something called the chain rule. It's a really easy concept, but it's really hard to understand when you write out all the reasoning. So when you write it out with the Leibniz notation. Just take the derivative as if the 3x minus 4 was a new variable. So let's say it's u. Okay, so if I have f of x is equal to 3x minus 4 to the 15, what I'm really thinking of is f of u equals u to the 15. All right, do you guys know how to take the derivative of f of u? Yes. All right, so the derivative of f of u is going to be f prime of u, which is 15, u to the 14. Okay, but what we had originally, the 3x minus 4, was not just one variable. It wasn't just x, right? It had other stuff with it. It had 3x minus 4. So what ends up happening is we always need to multiply by the derivative of what was inside. So the derivative of what was originally inside is 3x minus 4. So what's the derivative of it? 3. So if I was taking the derivative, what you're going to end up doing is you're going to have 15, 3x minus 4 to the 14, just like if it had been a new variable. But then you're going to tack on the derivative of the u term. So the derivative of the inside, which is 3. So we just multiply that on the very end. Okay, so here's y. Okay, so it says suppose y is equal to 5x squared minus 4x cubed. So I'm right here. Okay, and that's going to be equal to u cubed when we let u equal the inside part, the 5x minus 4. Okay, when you're writing it in the Leibniz notation, so dy over dx and so on, remember what that's representing. It's saying, so it says this is red, the derivative of y in terms of x equals the derivative of y in terms of u times, I'll write out times, the derivative of u in terms of x. Right, that's how it's written out. Okay, but what it's representing are the units. Think about units, right? It's a rate of change. So if I had meters for y and x was in seconds, dy over dx is in meters per second. It's change in y over change in x. So you go all the way back to your days in chemistry. Remember your days in chemistry? When you had like miles per hour, and then you could multiply by things like hours per something, let's say minutes, right? And then you could multiply by minutes per second. That's all we're doing. We're doing a unit conversion. So do you guys see it? dy over dx, the du's end up canceling. That's how you're getting dy over dx. That's what it's related to. It's related to units. So do you guys see the Leibniz, why it makes sense, why it's somewhat convenient to write it that way? All right, so you can think of it with this setup. You can think about the chain. This is why it's called the chain rule, because you're going to have something times something else times something times something else times something times something else, just like unit conversions. It's a chain of items. Or you can think about it as you always need to multiply by the derivative of the inside. So air quotes, inside. All right, so that's what we're going to do. So it says since physics, since derivatives are rates, it is the rate of change of y over the rate of change of x equals blah, 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 blah. So in physics and chemistry, you often cancel units. This is the same concept, so we're canceling our units. Okay, so it says the chain rule. If g is differentiable at x and f is differentiable at g, then let's say we have some kind of composition of a function. So we have f of g of x. So we have a function, and inside that function is another function. So for instance, that's like what we had, the 3x minus 4 to the 5th, or whatever we had, right? Your inside function is the 3x minus 4. Your outer function that you're plugging it into is x to the 5th. Do you remember compositions from algebra 2 and so on? So you take the 3x minus 4 and you replace the x with that. All right, it says this is differentiable at x, and f prime is given by the product. F prime of the inside times the derivative of the inside. That's the chain. So we don't forget it. We just take the derivative of the outer part just like normal. So when you look at this, you still do the 5, the 3x minus 4 to the 4th, right? But then we have to remember that it wasn't just a plain variable on the inside, so we multiply by the derivative of the inside. Does this make sense? See what I'm saying? Okay. All right, it says in Leibniz notation, if y is in terms of u, and u is in terms of, u is equal to g of x, I guess, are both differentiable functions, then what? So we're saying y, we're going to rewrite with u, and u is g of x. So it's saying y is equal to f of g of x. So we take the derivative of f in terms of u. We take the derivative of u in terms of x. You end up getting the derivative of f in terms of x. Oops. So do you see your original functions? Y was in terms of u was in terms of x. Okay. So for your examples, basically when you do these, you think about what the inside part is. So what your inner function is, like g of x. So your inside, you could write as g of x. It's 2x minus 4. Do you guys see that's the inside? If you had seen it like the square root of u, you would know that its derivative is 1/2 u to the negative 1/2, right? So we're doing the exact same thing. We're treating that inside part as a variable. And then at the end, we tack on the derivative of that inside part. Okay, so what we're going to have is, that's 2x minus 4 to the 1/2. So I'm going to have 1/2, 2x minus 4 to the negative 1/2. That's a negative 1. Kind of sloppy. Negative 1/2. And then I tack on the derivative of the inside. 2. That's it. So that is f prime of x. Well, what do you think you should do? 1/2 and 2, right? No. Easy. So you get 1 over the square root of 2x minus 4. Here's your answer. All right, so don't write out all that complicated mumbo jumbo. You don't have to write out inside g of x is equal to this. You don't have to write that out. Just remember the rule. If it's not a variable, right, it's not just plain u or x or whatever, you have to do the derivative of the inside. You have to do something else. So right now I have sine of x squared. So that's your inside part. That's your u. That's our inside. Basically, if I had sine of u, I know how to take the derivative of sine of u. It's just cosine of u, right? So if I do f prime of x, it's going to be cosine of that u value times du. What's the derivative of the u? 2x. So that's the derivative of the inside. What's the du? So that was the u, right? You were thinking of this as sine of u, and then you were taking the derivative of sine of u. So it was cosine of u times du. Do you guys understand what I'm saying? Yeah? All right, so if I have sine squared x, you need to figure out what the inside is. Air quotes, inside. Not just x this time. What is it? Sine of x. So you have sine of x squared, right? That's what that's saying. Hopefully you remember that from pre-calc. If not, we're in a world of hurt. Hopefully you remember that. All right, so f prime of x. So the inside part, we're thinking of this as my u, right? So if I had u squared, what's the derivative of u squared? 2u, right? So I'm going to have 2, and then I'm going to have my sine of x. That's my u. And then I'm going to have du. So derivative of sine is cosine. So this is my u, this is my du. So 2u du. All right, so the next one, it's going to be f prime of x equals 100, x cubed minus 4x plus 2 to the 99 times what? 3x squared minus 4, that's it. So you take the derivative just if the inside part was a variable, tack on the derivative of the inside part.
You can leave it like that.
Yeah, you can do it like that. You could say 300x squared minus 400. Is that what you're wanting? Alex wants to simplify more. All right, so how about this one? So let's rewrite. So it's really x squared plus 1 to the negative 1/4, right? Because it's a fourth root on the bottom. So you have a negative power. So f prime of x is going to be negative 1/4 x squared plus 1 to the negative what? 5/4 times 2x, because this wasn't just a plain variable, right? We learned the power rules for only just plain variables, so now we're learning it for other things. And you could think of it, I mean, if it had just been a plain variable, like if I had x to the negative 1/4, right? It's negative 1/4 x to the negative 5/4. What's the derivative of the inside then, though? 1. So it's still, I mean, you're still doing the chain rule, it's just always 1. So just think, oh, always do the chain rule. All right, here's a hard one. You ready for it? Yeah. See why it's called a chain rule? You can have multiple chains. Complicated. All right, so let's start with this being the inside. So u is going to be my cosine tangent x. So what I really have is sine of u, right, when I rewrite it with u values. So what's the derivative of sine of u? Cosine of u. And then I'm going to need my du, right? So I'm going to have cosine of, my u was cosine tangent x. And then what's du? Yeah, the du is the derivative of that. So du is going to be negative sine of the inner u times the derivative of the inside, secant squared x. It was 2 chains. I know, hard. Do you want me to write it out with u, u1, like different variables? So you can think of this as u1. All right, but then the derivative of u1 is, so u1 was equal to cosine tangent. It had an inner u. It had a u2.
Oh, man, you got them all.
I know. So it had a tangent x. So you have to tack on the derivative of u2, right? So this is the derivative of u1, is the whole thing, I guess. So the derivative of u1 contains the derivative of u2. Woo! Yeah, you could keep doing it. Like you could have kind of. No, because that part. So that part was the derivative of this part, and then the u, its du was there. Yeah, complicated. Do you guys want to try another one of those?
Yeah.
All right. So let's say I have number 7. So let's say I have f of x is equal to cosine of sine of cotangent. So you're always thinking derivative of inside, derivative of outside, derivative of inside. All right, so you have, this is your u that I'm underlining. So when I take the derivative, I'm going to have the derivative of cosine of u is going to be negative sine of u, right? So it's going to be negative sine of that inner part, the u. But now we need the derivative of u. So what's the derivative of sine cotangent x? Cosine cotangent x times negative cosecant squared. That's the derivative of the cotangent. Woo! Oh, chain rule. It can be hard. There's some tough ones. All right. So number 7, so find the equation of the tangent line to y equals 2x minus 4 to the 3 times x squared minus 1 to the 4 at x equals 0. Now, if this was on the calculator section, this would be a good one to maybe put in for your int deriv, right? Because you're going to be plugging in a number anyway. So you could always do that. But if I ask this like on a take-home test, you probably need to write out the steps, right? Pretend it's a non-calculator, I guess. All right, so y prime. So do you guys see that this is not only the chain rule, but it's also what rule? Product rule. All right, so we have 2x plus 4 to the 3, so keep that normal, times the derivative of the second part. So what's the derivative of the second part? Four. Yeah, you forgot your raised to the third. So 4 times x cubed minus 1 raised to the third times 3x squared. Are you with me? Only Isaac's with me.
Derivative of the first half.
All right, plus, not done yet. So now do the derivative of the first part. So you're going to have 4, not 4, what am I talking about? It's 3, right, on that one. So 3 times 2x plus 4 to the second times 2, that's that chain, times the second one normal, x cubed minus 1 to the 4. Do you get it? All right. Well, what's the nice thing about this? You're finding it at 0, right? So don't multiply it all out. That's a waste of time. You're finding it at 0. Plug in 0. So you get 4 cubed times 4 times negative 1 cubed times 3 times 0 squared. Oh, that's nice. It all goes to 0. Plus 3 times 4 squared times 2 times negative 1.
Shouldn't the second 4 there be negative? You plug in 0?
No.
Yeah, it should be negative 1. Because it's negative 1. The second parentheses, it should be negative. Can we share the point?
I have negative 1 cubed.
Oh, you shift and multiply together, yeah.
Oh, okay.
Take away,
That's why I thought. No.
All right, I just put it all to 0, right? It's all being multiplied by 0. I'm not doing all that mess. It's all multiplied by 0. It's gone. All right, so now how about this other part? So y prime of 0 is going to be 3 times 16 times 2 times 1. So what do I get? So 48 times 2, so 96. Is that right? 96. 96 is your answer. So that's 96 is your slope, I guess. So I'm not all the way done. It said find the equation of the tangent line. Right? So you need a point. So that's your m. Your point is 0, comma what? So if you plug in 0 into your original, so up here. So you're going to have 4 cubed times negative 1 to the 4th, so it's going to be 64, right? 4 cubed is 64. All right, so you're going to have y equals 96 is your slope, x plus 64 is your y-intercept, right? 0, comma 64, that's your answer. So y equals 96, x plus 64.
Sweet. So the first part of the equation there is cancelled out as 0 because of the last.
Right, all this goes to 0 because you were multiplying by 0, right? 3 times 0 squared. All right, so the next part, these are typical in the AP test. Every one. All right, so the AP test loves these ones where they don't give you a function. And you have to know to plug these things in. So I have these on your test, right? Didn't I have things like this? You would find the derivative. Yeah. Into the original. Right. At 0, you need the y value that goes with it. All right, so here, so if I do y prime is going to use the product rule. So I'm going to have f of x times g prime of x plus f prime of x times g of x, right? Doesn't matter if you flip the two parts. It's fine. All right, so if I have x equals 2, I'm going to have f of 2 is negative 3. G prime of 2 is negative 2, so I'm just finding these in the directions. F prime of 2 is 6, and G of 2 is 3. So I get 6 plus 18, so I get 24. So 24 is your answer. Not yet.
Good.
All right, then you guys had something like this next one on your test as well. So y prime is going to be low, d high, minus high, d low, all over the square of what's below. A lot of you guys forgot the square of what's below. So y prime of 2 is going to be g of 2, which is 3, f prime of 2, which is 6, minus f of 2 is negative 3. G prime of 2 is negative 2. G of 2 squared is 3 squared. So you get 18 minus 6 over 9. So you get 12 over 9 is 4/3. So 4/3 is your answer. You with me? The next two involve the chain rule. Do you understand that they involve the chain rule?
Yes.
It's not just x cubed, right? It's f of x. That's like your u. So if you had u cubed, you would need to do 3u squared and then du, right? So that's what we're going to do. So if I take the derivative, it's going to be 3 f of x squared times the derivative of the inside. Well, the derivative of the inside is going to be f prime of x, right? These ones are always on the multiple choice section. You need to know how to do these. All right, so I'm going to have y prime of 2 is going to be 3 times f of 2 squared times f prime of 2. So 3, f of 2 is negative 3, square it, times f prime of 2 is 6. So 3 times 9 times 6. Oh, what is that? So let's see. So 18 times 9. So 9 times 9 times 2. So 81 times 2, so 162. 162. All right, this also involves the chain rule, so see if you guys can get it. First step, you think about what the inside part is. So it's the g of x is the inside, right? So it's really f of u. All right, so the derivative of f of u is f prime of u times du. So you're going to have f prime of the inside, g of x, times g prime of x. Do not get confused and think that it's f prime of g prime of x. The inside part stays the same until the end when you multiply by the derivative of the inside. So we get f prime of g of 2 is 3. Maybe I should write it out so you guys can see it. So f prime of g of 2 times g prime of 2. So that's y prime of 2. So y prime of 2 is going to be f prime of g of 2 is 3 times g prime of 2 was negative 2. So that's why you had f prime of 3 in the original. Those happened because of the chain rule. Okay, so you're going to have f prime of 3 is 4 times negative 2, so you get negative 8. Did you guys get it? Maybe? Yeah? Good. All right, was that it? Do I have more? Yeah, that's it.